Hello everyone, welcome to DAA lectures. We are discussing unit number 1 and till now in this video series we were discussing about the calculation of time complexity of a given algorithm. But in this particular video we will be looking at how to calculate the space complexity of an algorithm. Right? So we have two types of complexity, time and space. Time we have already studied and now we will be looking at space. So let's start with the examples. On your screen, there is an algorithm in which we have an array, right? An array of size n. And we are putting 0 at each element of that array, right? So हमारे पास एक array है जिसका नाम हमने रखा है capital A. उसका size जो हमारे पास given है that is small n. And what we are doing, we are employing a for loop जो कि 1 से लेकर n तक चलेगा. That means it will be traversing each indices and it will be putting 0 at each element of your array, right? So in this particular example, we have the size of an array equal to small n, right? It is your input size. So ये कहाँ पर हम लोगों ने allocate करा गया होगा मेमोरी के अंदर. तो मेमोरी में हमने इंटीजर साइज का कितने ब्लॉक्स लिए? n blocks. That is equal to number of elements of your array. Second thing that which we have initialized in our memory is the loop variable I, and that is also of size integer, right? और उसको initialize किया गया है value 1 से. तो मेमोरी में कहीं पर एक integer size का ब्लॉक लिया जिसका नाम रखा हमने small I, right? तो एक ब्लॉक हमने किसके लिए लिया? loop variable के लिए लिया, right? So the total number of space that this algorithm will occupy in memory will be equal to n plus 1. N will be the array and 1 will be for the loop variable, right? So हमने कितना space लिया? n plus 1. But another thing that we need to understand while estimating the space complexity is that whenever we calculate the space complexity, we do not count the input space, right? तो जो input लगेगा आपका उसको हम count नहीं करते. तो यहाँ पे जो आपका input है that is what? That is the size of your array. तो यहाँ पर n+1 में से हम किसको निग्लेक्ट कर देंगे? n को, बिकॉज वो इनपुट है, वो मैंडेटरी है, एल्गोरिदम में होना चाहिए. स्पेस कॉम्प्लेक्सिटी कैलकुलेट करते समय वी जस्ट काउंट द एक्स्ट्रा स्पेस दैट वी आर रिक्वायरिंग, राइट? इनपुट इज मैंडेटरी. तो एक्स्ट्रा स्पेस हमें कितना चाहिए? सिर्फ एक स्पेस हम लोगों ने लिया है लूप वेरिएबल आई के लिए, इस सुडो कोड के लिए. तो जो हमारी स्पेस कॉम्प्लेक्सिटी होगी दैट विल बी बिग O of 1. वेरी सिंपल. Always remember the extra amount of space that we are costing, right? Let's look at another example and this thing will be clear more to you all. In this pseudocode or algorithm, what we are doing, we are copying the content of one array into another. So the input array is capital A and you are copying the content of capital A to another array that is capital B. So what amount of extra space we are here calculating or accommodating in the memory is size n of array capital B, right? तो वो input नहीं है, that is your output. So what we are doing here is that the size of array is n, that we all know. Then the variable that we require is again the loop variable, that is I. We are accommodating extra space capital B which is equal to your input size because you're copying the content, right? So the size will be equal. So this is the extra space. So what space complexity or how much space that we require? We require n blocks of capital B and 1 block of variable I. So the total space that we require is again n plus 1. And here this n belongs to your capital B, right? Now again the concept of considering the dominant factor. Here if n is very large then 1 will be significantly having no value. So the space complexity over here will be equal to big O of n. So now I think that the difference between the both algorithm is clear. In the previous one we do not require any extra space. All the manipulation of data was done within the input space only. But here we accommodate or we just have an extra space in the memory for copying the array. तो वो input में नहीं है लेकिन हम लोगों ने extra space लिया. So that is over here, that is big O of n. Let's go for another example, which is a little bit different. So in this particular pseudocode, what we have a two-dimensional array B. So now what we are doing, we are also copying the content A, but this time we have a two-dimensional array, right? So it is not equal to your, equal to your C program. There is a little bit difference, but आप समझ सकते हैं that what exactly we are trying to do. Here we are accommodating some value which is written in one array into a two-dimensional array. That means we will be repeatedly copying the values, right? So the variables that we require over here are two in number, that is I and j. Then we have an extra space that for, of course, your B array, capital B array, that will be equal to n square. Now this should be very clear to you all that a two-dimensional array is somewhat equal to a matrix. And if we have an n cross n matrix, then the number of elements present should be n into n, right? So if we have a 2 cross 2 matrix, so the total elements will be equal to 4, that is 2 into 2. So how many extra spaces that we will be required in an n crosses two-dimensional array, n cross n array, that will be n into n. तो कितना space लिया? N square space लिया, that is the extra space. So the total time complexity will be equal to n square plus 1, or you can say n square plus 2 because we are using two variable I and j, right? So you can also write n square plus 2. But again, we will be following the dominant factor rule. So if whether it will be n square plus 2 or n square plus 1, that plus minus 1 and 2 will be neglected and the dominant factor will be n square. So here in this particular example, the space complexity will be equal to big O of n square. So always remember that the input is mandatory, so that will not be counted into your space complexity. The space complexity will be equal to the extra amount of memory that you require to represent your output, as well as the amount of variables that you have initialized. But in the examples that we have quoted over here, the number of variables were only 1 or 2. So that was neglected. But if we have a significant number of variable initialized, they may somewhere counted into your space complexity. Otherwise, we always go for the dominant factor, as in the case of your time complexity. So I think the explanation of a space complexity in case of an iterative algorithm is somewhat simpler. I hope you understand all the three examples, and I shall be seeing you in the next lecture. Thank you.